Okay, welcome to the lab here. We get started in just a sec. Let everybody in. Go ahead and do your roll. Okay, so we'll get started here in just a sec. Give everybody another minute or so here to maybe come in. Um, so just a reminder, we're going to talk a little bit about the exam. We're going to talk about the lab today. We're going to talk about the formal lab part of it and sort of what that means and what you'll have to do for this particular experiment. And really in general for any other ones that are listed as a formal lab on the sort of schedule there as well. Okay, so first off, let's I guess talk about the um, let's talk about the exam. So the exam again is scheduled for Monday, and it will cover chapters 1 and 2. And remember, out of chapter 3, essentially it's electronegativity and basically what it is and sort of the trend on the periodic table. And after we just finish that last chapter, it should be pretty clear to you, hopefully, in general, what electronegativity is. So, again, that's what's going to be on the first exam, chapter 1, chapter 2, and just in terms of electronegativity, the trend that we talked about, along with those other periodic trends. Now, the exam will be most likely sort of a format like this. There will be basically usually two parts to it. The first part will be a multiple choice sort of section. And on that multiple choice section, obviously, you do not show any work or anything associated with that. It'll just be obviously read the question and, not circle the right answer or bubble it in, I guess, click the right answer in this case. Now, because there are multiple choice questions, that doesn't mean that they're all sort of theory type questions. There will be some calculation type based questions in the multiple choice part as well. So, a little bit of both in the multiple choice part, maybe some theory, maybe some calculations. So, I don't want you to think that they're all going to be just like, definitions or anything like that. It may be actual calculations or something like that that you have to do sort of in the multiple choice part. Probably not extremely difficult calculations or anything like that, but maybe some calculation problems along with maybe some, I don't want to say, I don't want to say definitions or anything like that, but maybe theory, I guess, is a better way of sort of putting that. Now, there will be that multiple choice part where, again, you do not have to show any type of work or anything associated with that. Then there will be a second part of the exam, which will be more like a written part of the exam. And on that part of the exam, there will be certain questions where you will have to obviously show your work. So what that means is you will need obviously a piece of paper to write down your work and show all your steps, just like you're doing any type of problem. That includes the setup. That includes significant figures. Um, Dimensional analysis, units. All that stuff, basically. Okay. So that part of the exam will be a part where you do have to show your work. The questions in the second part of the exam, where it's the written part, will be clearly labeled. Each question will say at the very beginning of it, you need to show upload work for this question, or it will say you do not need to upload or show work. So obviously, any question that says you need to show work or upload work in order to get full credit for that, you need to obviously show your work and upload it. In part 2 of the test, you also will be required to enter an online answer. And what that means is you need to enter an online answer, and that online answer does need to match the work that you're going to upload and have the same answer. So if you enter an answer online and you upload your work after you submit the exam and the answer you put online does not match the answer that's on your work, you get no credit for that question. So they do need to match, okay? So it's not a thing like I submitted my exam and then thought second about what I did and came up with a different answer. In addition, in order to get credit for any of those problems that is in the written part of the exam, you do need to answer the question online. So again, if you do not answer a question online or submit an answer online for the test, the work that you upload will not be looked at for that question. So you will not get any points for that question either. So again, just so we're clear, you have to submit an answer for every question online if you want some type of points for that. And that answer that you submit online does need to match the work that you will upload as well. Okay, so there's no like second thoughts about things or anything of that nature. So the second part of the exam, like I said, is more like the written part. You still need to show work. You still need to answer the questions online. And by the way, obviously the exam will be done through Canvas, right, on the Canvas site. And again, everything should be very clearly labeled for you as to whether or not you need to show work. Again, like I said, part one of the exam, which is the multiple choice part, you don't need to show work. You may have to work out some things to answer the question, but you don't have to upload work for the multiple choice part. Just the second part of the exam, which is the written part, for those questions that specifically say you need to upload work and stuff like that. Any questions on that part of it so far? Now, in addition, like I said before, you will be provided a periodic table as part of the exam, and you will also be provided any type of conversions that you need. Okay, I want to get to both of those questions. So, it is okay to use your phone and everything after you submitted the exam, yeah? So after you submitted the exam, you could use your phone to obviously take the pictures and convert it into a file to upload. That's perfectly fine. While you are taking the exam, you should not have your phone out or anything like that out, obviously, as well. So once you submit the actual electronic exam, you then can go and upload your work and obviously use those type of things. And ideally at that point, you have submitted an answer online. And again, it should match what you have, on your paper. So there will be. So I made a practice proctoral sort of exam module. We'll kind of talk about that in just a sec. But in the exam module for like the proctoral sort of practice one, it's going to be sort of set up the exact same way as your exam. So there will be an entire module, and in the module there'll be a couple of things that you'll have to kind of go through to take the exam. The first one is there's going to be an academic honesty type agreement that you need to read and sign, saying that you're not going to do anything you shouldn't be doing, obviously. So there'll be that you'll have to kind of go through in the module. And then once you do that, it will open up the exam for you to take. Once you take that exam, obviously it's going to be proctored by Proctorial. So obviously when you're taking the exam, you should not have anything out other than really a piece of paper or paper to write your work on. And then obviously a calculator. There should be no phones or anything out, obviously, in your work area when you're doing that. Once you submit the exam, that will then open up in that module a place where you could upload your work for the exam, just like you kind of do your labs and stuff like that. It'll be right there. It will open up and you can upload your work. And at that point, once you've obviously submitted the exam electronically that's being proctored by Proctorial, at that point, you then can obviously use your scanner, your phone, to take a picture or whatever you need to do to convert your work into a PDF file, and then you could upload it. Now, so there will definitely be a separate spot for you to do it. It won't be part of the exam that you have to do it. So with that being said, let's talk about an important aspect of that when you're taking the exam. Once you submit the exam, you should very quickly upload your work. So I'm going to give you a 10-minute window to do that. I don't think you really need 10 minutes. In my experience, most people could get it in within minutes of submitting their electronic exam. So you should be prepared before you take the exam as to how you're going to do that, how you're going to upload your work in a timely fashion. If you send me the work upload way later than that or extremely later than that, you're not going to get credit for those questions. Yeah. So this is not a situation where you submit your exam and then figure out how to work out the problems later. You need to do that in an efficient manner while you're taking the exam. Yeah. Okay. Give me 1 second. I'll get to that part of it in just a sec. Okay. Um, so let's just make sure we're very clear on the uploading part. So there's no misunderstanding. Once you have submitted your exam electronically for Canvas, it will then you then upload your work, and again, that does need to be done in a timely fashion. So you have like 10 minutes to upload your work. Again, anything that comes in after that point, you risk running the risk of not getting any credit for that, because in my experience, it should not take you all day to upload your work. Yeah, it should be relatively quickly. Once you complete the exam, I've seen them in like minutes of finishing their exam. It's like uploaded. So keep that in mind. And again, like I said, the work and what you submit online do need to match each other. So to sort of answer your question, uh, I'm going to give you the best answer that I could give you as not being a student. I personally haven't experienced it exactly how you'll experience it in terms of the proctoring. But again, my understanding of sort of what will happen is, you'll go through Canvas, you'll click on the exam, and you'll hit the start button. Basically, there'll be instructions, obviously, before it says start. And when you do that, I think it will also give you the proctorial part will kick in at that point, and it'll give you some information about, you need to have your camera on. You shouldn't move away, from the camera, get yourself prepared before you begin the exam and all that kind of stuff. So that's also a very good thing. Let's just talk about that. Obviously, it's going to be proctored by it. So you want to make sure that you are set up in a place to take the exam that's going to be good for you to do that. So you have obviously 4 or 5 days to sort of think about where you want to kind of set yourself up or how to set yourself up to take the exam. When you take the exam, obviously you shouldn't leave the camera view, because that's going to flag your exam and all that, and maybe even submit your exam for you. So make sure that you use the restroom or any of those type of things that you need to before you start to take the exam. And again, I personally would probably not move away from your camera for any purpose during the exam, because you don't want to get yourself locked out, get your exam submitted, get flagged, or anything like that. Okay. So, but my understanding is once you kind of click on the exam through Canvas, it will then open up, and I think you'll get a set of instructions of sort of what's going on in terms of the proctoring aspect of it as well. Yeah, so this is what I'm saying in terms of uploading your work. You should submit the exam first, and then that should end your exam experience. Okay. So that's what I'm trying to say. So once you're completed the exam, you completed all the questions, you're good, you're happy-ish with your answers, submit the actual exam. And if I understand this correctly, and I should be correct in this, at that point, the proctoring part of it will be over. And then you will be free to obviously step away from your camera, uh, you know, take your phone and upload your work. So is everybody clear? So so the exam part, which is like, you're answering the questions, you're submitting the questions, there is a submit button on the exam. Once you hit that submit button, that technically should end the proctoring part of it. Yeah. And then you should be free to, again, immediately grab your camera, your scanner, whatever you need to do. You could step away from the camera, whatever you got to go do there. And then you can upload your work at that point. I think it will be okay. There's some different levels. It may flag it if you can, maybe if it's possible not to have people maybe walk through the camera view, that would be probably the best situation. But if it's somebody that happened to walk by or something like that, it may flag you. And if I look at it, I could obviously tell, you know, they weren't standing over your shoulder, like pointing like, hey, do this, this, or this, you know, it's not going to probably be too big of an issue or anything like that. Okay. So that should hopefully be okay. So I just want to make sure I got everybody's question on that. So again, so that's why it's important. Again, while you're physically sort of taking the exam itself, you should be obviously working out your work, and then you should submit it. Once you submit it, you know, you could feel free-ish, if you will. And again, at that point, you should upload your work. And like I said, at that point, it should not take you all day to upload your work. Obviously, I can see when you submitted the exam, and I can see when you submitted your work, and they should be super close to each other in terms of time period. So again, we've submitted a number of assignments at this point. You should hopefully be familiar with how to do that, but you may want to think about just, you know, how you're going to do that on exam day. You also want to think about perhaps the location where you're taking your exam, if it's possible to move or whatever, if you need to a place where, you know, there won't be much disturbances or stuff that will be sort of captured on the camera that may flag your exam or anything like that. Any questions on that there? Now, in terms of the exam itself, like I said, there is 2 parts. There's part 1 and part 2. And like a normal exam, that if you were taking in person with me in class, you will be able to see every question at once. So they're not going to come one question at a time. You'll have the entire exam given to you when you open it. You know, every single question, all the multiple choice questions will be there. All the, you know, written part will be there as well. So it'll all be there at once. So you could work just like normal in any order you want. You know, you could go up, you could go back, and sort of work the exam however you want. Now, the important part is there is one button at the very bottom that says submit. And you do not want to hit that button until you have completed the entire exam. You've answered every question that you are going to answer or want to answer. You should hit the submit button only once. If you hit the submit button before you've completed the exam, there actually will be a little window will pop up and go, are you sure you want to do this? You left like 32 questions unanswered. I don't know if there's that many, but, you know, 32 questions you didn't even answer. So it'll actually give you a warning in case you accidentally do that. So make sure, again, you do not hit the submit button for the exam until you have completed the entire exam, the multiple choice part, the written part, and all that kind of stuff. So you want to make sure you do that once. If you submit the exam before that, it will not be reopened for you. So make sure you don't submit it until you're ready. There will be a time limit on it. To be truthfully honest with you, I don't know. You're going to get maybe like 2.5 hours, I think, something like that. Maybe like 150 minutes, 135 minutes, 135 minutes, something like that. So 2-ish hours or so, I think, to take the exam. So you'll have some area in that time period, either like 135 minutes or 150 minutes, whatever that works out to sort of take the exam, I think. Okay. With that being said, as well, there will be an availability window for the exam, and you do need to take it during that time. So what that means is, if you start the exam, and I think this time around we're going to start it around lab time. We're going to start taking it at that point. So if you start it around our normal lab time, you should not have an issue with sort of the time limit or something like that. We may start a little bit earlier, maybe in the lecture period, but we'll start somewhere in that ballpark, I think, around where lab starts. But if you started at that particular moment in time, you should be fine. If you wait too long to start the exam, the computer will cut you off. So for example, let's just say you had 2 hours to take the exam, and the cutoff time for the exam, the end of availability time, or the due date and time was 1 o'clock. And you decided, oh, I'm just going to start it at 12:50. If you start the exam at 12:50 and the end of availability is 1 o'clock, the computer will only give you 10 minutes to complete that exam, regardless if you're supposed to have 2 hours to complete it. So it's very important to take it when you're supposed to and start it when you're supposed to. Again, if you choose to start too late, you get whatever time the computer gives you at that point. So it's just like if you're in person and you came 40 minutes late to the exam, you lost that 40 minutes, right? So that's why it's really important to be ready to take the exam at the beginning of when it's ready to start. Again, this is sort of a real-time class, right? So you need to be ready to take it. And again, if you for some reason choose to start too late, the computer will cut you off and it will submit your exam for you. So it's really important to make sure that you start it at the right time, so you don't run into any of those issues. So if you start it right around, you don't have to start it exactly on the nose on the start time, but if you start pretty much within that period of time when the exam opens, you shouldn't run into any of those problems. But if you do start a little bit too late, again, the exam will cut you off the computer and it will like auto submit it for you. And, at that point, it is what it is. It will not be reopened for you either. Okay. So make sure that you, start the exam at the appropriate time. So let's see, start the exam at the appropriate time. Don't do anything dumb, all those kind of things. By the way, there's different versions, right, as well. So that's a good thing to keep in mind too as you're taking it. Okay. So again, you'll have a periodic table given to you. You'll have some conversions given to you. Some questions, there may be some images sometimes in the questions, maybe not this exam, but other exams as well. And so usually I may put like a PDF file in there in the question as well, just in case you can't see the image and stuff like that. So if at any point in any exam, not necessarily this first one, for example, but in any point in any exam, if there's some type of image or something like that, there's usually will be sort of a backup file for it, just in case, like a PDF file, just in case. I know sometimes depending on updates and browsers and stuff like that, sometimes some people can't see a particular image and some people can, and that type of situation. So usually there'll be some type of backup file in the question itself, and just in case you can't see the image. So keep that in mind. But most of the time I try to, as much as I can, try to avoid images and stuff like that, because I know sometimes that some people have issues with it. But usually if I have to put an image or something like that into a question, there usually will be some type of PDF backup file in the question that you'll be able to open. And it will allow you to open that file the way I'm going to set it up. So you will be able to open that file if you need to. Any questions on that? Okay, so some of the highlights, again, just for the exam. Again, it will be in a module, so very similar to kind of the thing I set up for you to kind of practice with. You'll have to go through the steps in order in the module in order to open up the next step in that process, which again means usually, again, the first thing that you'll have to do is sign the academic honesty agreement. You could do it electronically, so there'll be a way you could just kind of type in your name and initials, and that will serve as sort of your signature. Once you do that, it will open up the actual exam, which again, at that point, you'll get instructions for the exam. You'll get instructions from proctorial probably about what's going on. And by the way, you should not hit start the exam until you are absolutely ready to start the exam. Once you start the exam, the timer will start. So once you start the exam, the timer will start, and it will not stop for any reason. So even if you happen to have clicked away from the exam and come back to the exam, your timer will still be going. So make sure that you are definitely ready to start the exam before you start it, because as soon as you start it, that timer runs, and again, it will not be reopened for you for any reason. So if you start it, you better finish it. You can't come back to it or anything like that. You got to roll through it the whole way. Again, once you've completed all your questions, you've answered questions online for every question. For any of those questions that have work associated with it, you worked it out on the paper. At that point, again, if you answered everything, you should submit the exam. That should stop the proctoring process in terms of the exam. That also then should open up the assignment in that module for you to upload your work again in a very timely fashion. When you do upload your work and stuff like that, again, just make sure that it's sort of legible, if you will, not too dark of pictures or anything like that. Most cases it's okay, but just try to make sure, I could read it. Obviously, normal rules apply. If I can't read it, I can't give you credit. And by the way, all your work should be done handwritten, like on paper. Yeah, so not on computer, not typed or anything like that. It should be done on a piece of paper, pen, pencil, and handwritten. Any questions on the actual exam? I think that covers most of it. You will see probably on the exam, there will be a lot of instructions written. And again, the instructions are there just so I try to think of everything that could possibly happen for you. You know, that will hopefully allow you to get any questions that you might have answered. Any questions on the actual exam part? Okay. I think I got everybody's stuff. I think I'm not. Okay. So, like I said, I did make a sort of practice sort of quiz. I think there's like 5 or 6 sort of easy-ish type questions. I think some are true, false, or like multiple choice and stuff like that. So I set up this practice one for two reasons. One is sort of set up like how the exam module will be, and it's not up yet. It'll be up very shortly. But you'll see on there, there'll be the quiz that you need to take. And then after you submit the quiz, you'll need to upload an actual file. So part of the practice one as well, again, is just to make sure you understand, you know, after you submit the practice quiz, you need to upload something. Right now it's set to once. I think it's set to once. I may give you, I don't know if you, I may give you an extra shot at it. So I'll give you 2 shots at it, the practice one, if you want. Again, it's not going to count for any points towards anything or anything like that. But just in case you want to kind of do it twice or something like that, you can. I don't know. Right now it's set to 1. So I might change it to 2, and that should hopefully be enough. I think practice, I would hope. But again, it's not going to count for anything in terms of points. It's really just to sort of get you understanding how it's going to work so that you're not trying to figure that out, obviously, on the day of the first exam while you're trying to take the exam, okay? So again, you'll submit the practice one. You then will also have a file to upload. I think it's just print your name and sign your name on a piece of paper and upload it, and that's, you know, what we're going to do. And that'll be very much like what you'll have to do on Monday for the exam as well. Again, there'll be the exam you got to take, then afterwards you need to submit it. So this just gets you thinking again as to how you're going to sort of do all these things. You want to think about how you're going to do all these things in a timely fashion. And again, give you an idea setup wise, you know, is it good the way you got it kind of set up? Any questions on that? So that practice one will be up, you know, in just a little bit, sometime during lab. And again, you'll have it, you can take it anytime today through like Sunday, I think is open for you to take. And maybe I'll give you 1 more attempt. So I'll give you like 2 attempts at it if you want to do it twice, just to kind of see it. If for some reason you need more, you could email me, but I hopefully you don't need more after that point, I think. Any other questions on that? Okay, so that should take care of the exam part, I think. So as of now, I think we're going to take it, like I said, towards lab time. So we may have a small lecture, not the whole time. So we may just lecture on a couple of things. Then we'll take a break. That way you can kind of get yourself set up and ready to take the exam. And then the exam will be open at that point, again, heading towards probably around the start of lab. It may even open up a little bit before that as well. And again, we'll just do maybe on Monday, we start at 8. So we'll just do maybe a lecture from like 8 to 8:30 or something like that, or maybe a little bit more than that. So, and then they'll kind of give you a little break. You kind of get yourself set up and ready to take the exam. And then again, it will open the latest at 9:45, but it might even open a little bit earlier than that in case you want to kind of get it started with and stuff like that. Okay. Even if it opens up early, no matter when you take it, you will have the same amount of time. Again, the only time you would not have the same amount of time is if you chose to start it way too late and the computer cuts you off. All right, any other questions on the exam or anything like that? Hopefully you went over most of that and that made sense, I hope, yes. Okay, then we actually do have an experiment today. So today's experiment is magnesium. It's the percentage of water in a hydrate. And the hydrate that we're actually looking at is magnesium sulfate, I think, heptahydrate. So hydrates actually have a kind of unusual formula. They have this little dot between the 2 parts of it. And really, there's two parts of a hydrate. There's the front part that comes before the dot. And this is really the salt part. And a salt is really just an ionic compound. And that's, again, a positive and negative guy. And there is basically the other part that comes after the dot, which is the water part. And that's what's known as, that's the water part. We'll go with that. And the water part is really what makes it a hydrate. And this entire thing here is all together. So sometimes we think about water and we think water is liquid, but this is all actually a solid. And when this magnesium sulfate crystallizes, along with it in that process, there was some waters that, you know, kind of came along for the ride, and the waters actually crystallized with it. In this particular case, hepta means 7, hydrate means water, so that's what it means when we say heptahydrate, that there's basically 7 waters, sort of. I think I got 7 there, right? 1, 2, 3, 4, 5, 6, 7. There's basically 7 waters that are crystallized with this solid. So we do this little dot, and it doesn't mean multiplication or anything like that. It's just the way that hydrates are written. So what we're going to do basically in this experiment is we're going to take this hydrate and we're basically going to heat it. And when we heat it, basically it becomes water. These solid water crystals basically will start to evaporate, if you will, and the water will come off. And we will be left with the magnesium sulfate plus the 7 waters. This guy with the water all together is what's known as the hydrate. When you sort of heat off the water at the end of the experiment, this is what is known as the anhydrate, which means it does not have water associated with it anymore. And that's sort of the goal of the experiment here, is to drive off that water. So why is that important? That's important because we know that if we started with this guy, what we're essentially going to do is they took a ring and a ring stand, and they took a crucible with a lid, and they took some Bunsen burner there. That's a nice looking Bunsen burner, I guess. We'll go with that. And basically they put the hydrate in here. So they started with a certain amount of hydrate, and they started to heat it. And I believe they heated it for the first heating for like 12 minutes. Yeah. And after the first heating, they weighed it, and then they put it back up and they heated it again for the second heating, which was, I think, another 5 minutes, I think. Now, the process of heating this obviously is going to cause this water to start to evaporate off. So in person, if you were seeing that happen, you know, you see a little bit of steam coming out the top. The lid could either be on completely, or it could be slightly ajar to let some of that steam out, and that water will kind of evaporate off. So they reweighed it, and the goal here is to continue to heat until they hit constant mass. And the purpose of that is when we hit constant mass, we will know that we pretty much was able to drive off all the water. Yeah? Because we know the water is essentially the only thing that's going to leave this hydrate. So by heating it until we keep weighing it until we hit constant mass. So I think the constant mass was, I don't remember off the top of my head, like 0.01 difference. And that is basically between 2 weighings. So for example, if I had 50.050 for my first weighing, and for my second weighing, I weigh at 50.049 for my second. The difference between that, it's a lot of math there, but I think difference is like 0.01 grams. Essentially, the first weighing and the second weighing are basically the exact same mass. And that means that you have successfully pretty much have eliminated all the water. Now, if you did your second weighing and you had something, say, like 50.000, the difference was between this one and this one, like 0.05 or something like that, which is a lot bigger, which means you might still have water in there. You would have to put it up there and continue to heat. So the idea here is we heat the hydrate, we let it cool down. We always want to let it cool down before you weigh it. You weigh it, you heat it again, you let it cool down, you weigh it. Then you want to compare those two weighings and see if the masses are pretty much constant. In the actual procedure, it tells you what that number is. And again, I don't remember off the top of my head what it is, but the difference between those two numbers need to be a certain number like 0.01 or 0.05, 0.001, something like that. And if it's not, then what you would do is you would take it and put it back up on the ring stand. You would heat it again. You would let it cool down and you would re-weigh it. And you would continue that process of heating, cooling, re-weighing until you got two mass measurements back to back that essentially were the same number or pretty close to the same number. And again, that would be constant mass. So sometimes that might take people 3 heatings. Sometimes that may take people 4 heatings to do it. In my experience in this experiment, usually it takes 2 heatings like it does, I think, in the video. So usually it's only 2 heatings to get there. But it doesn't always have to be 2 heatings. It may be 3 heatings to get to that constant mass. But the idea behind the constant mass is once you hit constant mass, you pretty much know that you successfully have driven off, in this case, all of the water that was there. So we're going to say here, just like in the video, I think that the second heating after we did it, we hit constant mass, which means after the second heating, what you have left, if we hit constant mass, and you look at your crucible, what you have left in your crucible at that point is the anhydrate. So this is what was in the crucible at the beginning before you started to heat. So that was what's in the crucible. And as you start heating the first heating, as you start heating the second heating, once you hit constant mass, this is what's in the crucible. Which means if you subtract the mass of the hydrate when you started from the mass of the hydrate at the end of the experiment, which is what was in the crucible, which at that point is the anhydrate, the difference between those two is the mass of the water. So if you take the mass of the hydrate that you started with at the beginning of the experiment, minus the mass of the anhydrate, which you are left with at the end of the experiment, that will give you the mass of the water that was lost. And that's important because what we're looking for is the percentage of water, which means we need to get the mass of the water lost divided by the mass of the hydrate times 100%. So the mass of the water lost is experimentally is going to come from your experiment. This is going to come from the mass of the hydrate you started with. And you'll be able to figure out the percentage of water that was in that hydrate. So what we just walked through is basically the experimental percentage of water in your hydrate. Any questions on that? Now you could also calculate the theoretical percentage. And that is based solely on the formula, magnesium sulfate dot 7 waters. Now, to do that, you really need the molar mass of this guy. And that is going to come from the periodic table. So if you look on a periodic table, right? Look at hydrogen, for example. Underneath hydrogen is this number, and you can use that for the molar mass. It's really the atomic mass, but we could use it to calculate the molar mass. And if we were to add up all the parts, basically is what you need to do. So for example, there's 1 magnesium. You need to go to the periodic table, get the molar mass of 1 magnesium. There's 1 sulfur. So you need the molar mass of 1 sulfur. There's 4 oxygens. So you need the mass of 4 oxygens from the periodic table. And the thing that most people mess up on is they forget all about the water part. You need to include that in your molar mass. So that means that there are 14 hydrogens for the 14 hydrogens that are there. That also means that there are 7 oxygens. So you basically need to go to the periodic table. You need to add up all those parts, and that will give you the molar mass of your hydrate. Now, once you get the molar mass of the hydrate, the entire thing, you need the molar mass of the water that's there. And again, in the formula, there are 7 waters, right? Which means you need to go to the periodic table again and get the mass of 14 hydrogens and 7 oxygens, right? We'll give you the molar mass of water in that particular hydrate. So now you would have everything you need to get the theoretical percentage of water. You would take the mass, the molar mass from the periodic table of water, which is this number, again from the periodic table. You would divide it by the molar mass also from the periodic table of the entire hydrate. So that's the 1 magnesium, the 1 sulfur, the 4 oxygens, and the 7 waters. And you would times it by 100%. So that will give you your theoretical percentage of water in that hydrate. The theoretical percentage of water in the hydrate is ideally what your experimental percentage should come out to. They should hopefully be very close to each other. So there, in this experiment, there's really 2 types of percentage of water that you're going to calculate. One is based on the experiment and the experimental information, which is the experimental percentage. And one is based on the actual chemical formula, like we see on the top right here, of magnesium sulfate heptahydrate, where you need to use the periodic table, add up all the parts, and calculate it that way. Any questions on those 2 sort of calculations? Now, the last thing that you're also going to calculate is what's known as percent error. And percent error is like your absolute value of your theoretical minus your experimental value divided by your theoretical value times 100%. So this would be your theoretical value. The experimental value, again, would come from the previous page where we did the calculation. You take the absolute value of it. So if you get a negative number here, you can make it positive. And when you calculate percent error, you're looking for actually a low number is good. Yeah. So if you have like 1% error, that's pretty good. You have 0.2% error, that's even better. If you had like, 75% error, that's not so good. That means you probably did some things really wrong in this experiment. So when we calculate percent error, what we're looking for is really a low number. It also tells us really what percent error tells us is based on our experiment, how close we were to really the true value it should have been. So in our case, the true value really should have been the theoretical percentage. And we're going to use our experimental percentage. And what we're really dealing with percent error is comparing how good the experiment was done, right? So again, if we get a very small percent error, that means that the experiment was done really well. And our experimental error, our experimental percentage is very close to our theoretical. Again, if you get a very high percent error, that means most likely something went wrong along the way, which will also sometimes tell you, you kind of think about what maybe went wrong in that particular experiment. Any questions on sort of the experiment itself or the calculation part? Okay, so let's talk a little bit about this experiment. It technically is our first sort of formal experiment. And formal experiments do require a typed lab report. So this lab obviously is not going to be due today. It will be due sometime next week. And it does need to be sort of a typed version. And just to show you here a couple of things. Up on Canvas, I did upload some lab stuff that will sort of walk you through some of this. Let me just find where I want to go. Hang on one sec. Let me go this way. There we go. And let's go that way. Okay, so if you go to our Canvas page here, you will, and you go to the module page. Hopefully, there we go. You'll see this new sort of module that's up there, and it's for labs. And it describes sort of just in general mini labs, which is kind of like what we've been doing, sort of the ones where you just kind of do the experiment, fill out the paper, and then upload it. And then they're more formal labs. So the formal labs, again, are the ones that are labeled formal, and this is the first one. So Professor Wada has provided some examples of what things should look like. So first off, for the formal labs, this is the part where you should be using your carbon pages in your notebook. So in your lab manual, towards the back, again, there's a set of carbon pages, and you should be using those in these experiments to record your information. So in the actual experiment, there's tables, but you should use those tables as sort of a reference to set up your lab notebook. So let's take a look at his lab notebook here, his example, just to give you sort of ideas of what's going on. If I could get it here, maybe a better way. Let me see. Try that. That will work, I think. All right. So here's an example of the carbon pages. Again, these are like the carbon pages that you would find in the back of your notebook there. And you should have, as you see here, the purpose of the experiment in. By the way, you should have the title, obviously, your name and the date you're doing it. And again, you do need to record this stuff, even though you're sort of watching a video. You need to record all the information in your carbon pages. You will need to upload these carbon pages as part of your lab report. So you're still going to need to sort of do that. So name, date, experiment number, you need to have a purpose, the equipment that's going to be used. By the way, he did a pretty good detailed on this one, so try not to copy his exactly. Yeah, so try to at least use your own words and stuff like that. And usually in a lab notebook, it's really important to have two basic things. And one basic thing is, as you can see here on the left, is the actual procedures that are going to be performed. So in these formal experiments, you should have the list of procedures that's going to be performed. And most importantly as well, you should also have observations and obviously measurements that are made. And a very common way people sort of organize their notebook is in this sort of two-column approach. So one column, for example, is where we list all the procedures, kind of numbered so we know exactly what step we're on. And in the column on the right is our observations and our measurements. So for example, record the mass of the empty crucible. When you do that, you would put the number here on the right-hand side and record what it is with the proper digits, the proper number of units and that type of stuff. Maybe you have an observation like, hey, the thing turned purple. You would record that here as well. So in a lab notebook, you do want to kind of follow this sort of technique here. Do you have to do sort of the two-column approach? You don't. You could do more of a paragraph form. But whichever way you sort of choose to do it, it does need to be organized, and you do need to have the procedures in there. You do need to have the observations and the data that you're doing in your notebook. In addition, like I said, in the actual experiment, you will find a table that looks very much like this. And when you're doing this experiment, you technically should have a table like that in your lab notebook. So you want to make a table like that. That's essentially where you could put all your information in a very organized way. So you could do all your information here in a very organized way. You will also see in those tables some numbers next to them. And in those numbers, those are entries in the table that require calculations. So for example, number 1 is the mass of the hydrate. And that has a 1 next to it, which means in order to get that value, that is a value that you actually need to calculate, which, by the way, you would do by taking the first entry here, the mass of the crucible, lid, and hydrate, and subtract it from the mass of the empty crucible and lid. So for example, in order to get number 1, you would actually subtract the first 2 entries in the table to get to number 1. You also see there's a space where you could show those calculations, and you do want to show those calculations with the units, the setup, and everything sort of correctly. So you do want to organize your lab notebook into this sort of format, and make sure that you look online here for sort of the format so you understand it. And the purpose of this lab notebook is to really set you up very well for the lab report that you have to write. So if you sort of set up your notebook with all this stuff in there, organized, a nice table, the calculations, when it comes to writing your type lab report, it should be a breeze pretty much. It should be very, very easy to do because you pretty much have everything you need in your notebook. Any questions on the notebook and sort of how to set it up there? Now, here again is another one that he put up there, sort of what it looks like after the experiment. And I think this one will have some stuff written in, I believe. So you can see as he was watching not watching what he would have been doing the experiment, but as of watching it there, he'd be filling in that information. Exactly. So for the formal labs, that's essentially it. In reality, for this first formal lab, when you look at the actual experiment, it'll look very much like all the other ones. There's like all the tables, just like all the other experiments. And what you'll gradually see is as we move down the road into further formal lab experiments, there'll be less of that sort of stuff there, and you technically need to sort of have this stuff in your notebook. So you could kind of still use it. You could use the stuff in the notebook and the manual as sort of a guide as to how to set up your notebook. But really for these formal experiments, you should be recording the information in the carbon pages. I'll get to your answer about the pre and post lab in just a second, okay? But in terms of filling it out, as you can see, as you go through the experiment, again, there's some observations that you should have in there. And again, more observations. And you can see because he arranged this nice data table as he went through the experiment, he obviously was filling in the information. And obviously here is the sample calculations with the units and how to do all those type of things. And again, if you do all this, this will set up your lab report really easy for you to do because you essentially just need to copy your lab notebook pages and you'll be good. All right, so that's what that looks like. And what do we got left there? So the lab report for this one is a type lab report. And you can follow this procedure or this sort of sample as well. And again, I ask you not to copy it word for word, but do your best to try to turn it at least into sort of your own words and all that kind of stuff. I know it's kind of similar how it should end up, but try to follow this format. So this format, again, as you can see, it is actually typed. So they do have to be typed, not handwritten. Again, you have your name, you have the title, you have a little bit of the purpose, you have the equipment that's going to be used. In sort of paragraph form, you have the procedure that you did. You also have some of your results as you went through. Again, this should be paragraph form, sentences, not like bullet points or anything like that. Again, it should kind of flow as almost like a paragraph, obviously. And again, you can insert, obviously, your values in there. You will also see that you do need to make a type table. So you do need to create a table. You could either do it in Word, you could do it in Excel, some way, but the table does need to be entered into your type lab report. Now, the calculation part you could do by hand is fine. You don't have to type that, but you do have to sort of make your own type table. And again, for the calculations, you could just do them by hand. And then at the end, you'll have a conclusion. Again, a paragraph type form. When you talk about the conclusion, you do actually want to mention your results. So very often people get to the conclusion part and they're just like, well, the experiment went well. The end, but you did all these sort of calculations up here, right? You did things like the percentage of water theoretically, the percentage of water experimentally, the percent error. you want to actually, when you get to the conclusion part, sort of mention, obviously, those important results. So actual numbers, actual values should be entered in here. Again, though, in paragraph form, you shouldn't just list them all there. Again, you should just do it in paragraph form and sort of sentence structure. So this is what the typed lab report looks like. It does need to have this same format. And again, the entire lab report does need to be typed. The only thing that in the typed lab report that does not have to be sort of typed is the calculation part. You could do that by hand and write it by hand. Now, to answer your question about the pre and post lab, when you are completed with all of this, you should have a typed lab report that has, again, the table and the calculations in the lab report. You can't just say, I did it in my carbon pages. You do have to have it as part of your lab report. You need to attach your carbon pages to it. And you need to have the pre and post lab questions attached to it as well. For the pre and post lab questions, you could just answer them on the paper like you've been doing. So you could take the manual pages and just work out the pre and post lab questions just like you were doing before. You then need the type lab report and you need the carbon pages. Okay, so for the pre and post lab, you do need to do it, and you can just do it in the manual pages and then attach them. So the carbon pages are in your lab manual. So I can't really show you that, unfortunately, but let me just try to explain it so everybody's clear. The lab manual, the thing that you've been using to do the experiments that we've done up until this point, when you open that lab manual, in the very front part is pretty much all the experiments, right? So it's like experiment 1, here's the procedure, here's the papers. When you get done with all those kind of experiments, then the study assignments, right, come next, I think. And then in the very back of the lab manual, there is papers that look sort of like these papers here. Looks sort of like, you'll see pages in there that sort of look like this. It might be hard to see, but there's kind of lines. Sometimes there's kind of boxes on it. There'll be some pages that look like this page, not written on, obviously, but the page itself. And the carbon pages it's really carbonless carbon. So there's like a little flap type thing, right? In your lab manual, it has some values on it. It's like a little flap that you can kind of open and flap. Usually if you open that flap in the back, that's where you'll find all the kind of carbon pages. And usually I'm trying to remember, I think the top page is like whitish and maybe blue. But there's basically 2 pages together, and it will make basically a carbon page. And you basically put the little divider between the 2 carbon pages, and that will make a carbon of it. Yeah. So that's where the carbon pages are. And basically what the carbon pages is, because it'll make a carbon copy, right? So the top copy you usually keep, and the bottom copy is the carbon part that you usually would turn in with your lab report. Now, when you do that, again, it will make a copy of it for you. So you need to give me whichever one I could kind of read. So if you see that the carbon pages, it didn't go through very well, and I can read the top one better, give me the top page, or give me the carbon page, whichever one I can kind of read better. Yeah, so you kind of have to do it twice, if you will. I don't want to say twice, but again, if you do a very good job in your lab notebook, when you go to type your report, it should be fairly easy, because essentially you will have, everything that you need. But the main difference between sort of the notebook is, as you can see here in the notebook, you could kind of do almost like a bullet points if you want. But in the type lab report, the procedure and all that should be paragraph form, kind of sentence form, and that type of structure. So it is essentially kind of the same thing in both places, but really the 2 main differences is the lab notebook is really your record when you're performing an experiment. So it's the record of what you saw, what you did, and what you recorded as being important as you were actually doing the experiment. And if you do it in a very organized fashion, like what we see on the screen, that will set you up for your lab report, which is essentially when you take all that information and sort of analyze it as to what it means, and more of a paragraph form, more of a paper type form than just sort of here's some bullet points of step 4 and I saw this, or step 5 I saw this. You want to kind of in words do it. So essentially it's kind of the same information, just sort of displayed slightly different in sort of a different format. Yeah, so they're not going to be due today, the pre or post lab questions. I just want everything all at once, so everything together at once. So you'll turn in the pre and post lab questions along with your type lab report and along with your carbon pages all together when it's due. Normally when we're in person, I go around and check your pre-lab questions, but I'll just assume you did them in the appropriate manner in this case. Now, let's just be very clear about this. This is individual work, just so we're clear. The typed lab report should be your own individual work, your own words. So I should not read 2 lab reports that sound exactly the same. Are they going to sound similar? They probably are, but they shouldn't sound dead on the same. So for example, I shouldn't have a deja vu moment when I read one lab report to the next, like I've seen before. And a very bad example was perhaps, somebody had a sentence with a badly spelled word and some bad grammar, and the next person had the exact same sentence with the wrong word and the wrong grammar and stuff like that. So, that shouldn't happen. Again, it should be done individually. And that means if you have a friend or something and they ask you to send you their typed lab report so they can see the format you used, I probably wouldn't do that because, they're going to lift it from you probably there at 2 a.m. before it's due, and maybe borrow it. And again, if I see 2 extreme similarities in the reports, everybody gets zeros. I don't know who did what in that case. All right. So I understand completely that they're going to sound very similar. I understand completely that it's going to be very similar to the example that's up here. But again, I just ask you to try to do it. Obviously, you should do it yourself in terms of the type lab report. And obviously, you should try not to copy anybody's report, especially Professor Wada's report here, word for word. Again, you should try to do your best to turn it into your own sort of version of it. I understand it might be a little bit difficult with certain experiments like this one, but again, from the outset, it should be sort of individually done. Any questions on that? Okay. So lab report that. So that is sort of the setup here for our formal lab, and sort of the kind of overview there of what's going on in terms of the calculations. Is there any questions on any of that stuff there? So technically scheduled, the experiment scheduled for today, technically Monday when we're going to take our exam, the calculation part scheduled. So I'm trying to think here, we will go with the lab report will probably be due towards the end of next week. So sometime towards the end of next week, either Wednesday or Thursday. I'm thinking maybe Thursday, we'll see. But sometime next week, it will be due officially, the type lab report. And again, just so we're clear what that should consist of, so there's no misunderstanding, hopefully. Your typed lab report, or your lab report for this one, you should have your pre-lab questions. And again, you could do it on the manual pages. You should have your typed lab report, which includes all those parts, including your intro, right? Your, whatever it was, your procedure, if you will, your data table that's typed, your sample calculations, or your calculations that are there, your conclusion, you should have all those parts there. Again, all typed. And then you should have your post-lab questions. Also, you could do it on the manual pages. And lastly, you should have your carbon pages. So that, and that. And if you could, kind of put it in that order. Yeah. So kind of put it in this order here. And I'm thinking it's going to be due sometime next week, maybe Thursday. I'll let you know for sure, but somewhere in that ballpark. Any questions on any of that? Obviously, there'll be an assignment for you to upload it, and you can upload it at that point. Any questions on any of that? I'll trust you. If next Thursday is the 29th, we'll go with that. Why not? It's the first one, give you a little extra time. The box for you to turn it in will be up there earlier than that. So if you finish it before that, you can turn it in whenever you want. But we'll go with the latest on this first one. You won't have this much time probably on the rest of them, but with the latest here, we'll go with next Thursday. So that's the 29th. You said? No, we should be in July at that point, right? Today's the 20. What is today? It's like the 25th, I think, right? So July at that point. Yeah, that'd be like July 2nd, they say. Yeah. So July 2nd, yeah. I'm like, going quick here, right? We're done 2 weeks. We only got 6 more to go, I think, right? So that's good. Any questions on the experiment, anything like that? Okay, so I'm going to, like I said, at this point, be quiet, I suppose. But I'm going to go turn on the video. It's not up there yet. So as soon as we're done talking here, I'm going to go click it on for you. You could watch the video again if you want to, whenever you want to kind of do it at this point. Technically, it was scheduled for today and next Monday. So you do have some time to watch the video. If you want to kind of go through what's up there on Canvas and kind of get your notebooks organized and all that kind of stuff, or work on the pre-lab questions, or watch the video whenever you want to do it, now or whenever you can. And again, like I said, at some point there will be a box for you to turn it in, and again, you can turn it in anytime you like, but the latest will be next Thursday. It will be officially due, but again, you can upload it whenever you like to do that. And I will also turn on that practice quiz. And again, I would recommend for the practice quiz to not just go take it, to see what it's all about. But I would try to set yourself up like you are going to set yourself up to take the actual exam and then take the practice one. Again, so you can make sure everything is okay in terms of environment and how you have things set up and stuff like that, okay? Any questions on anything like that? And again, if you do have questions, I'll be around, I might have the camera off and all that, but I'll still be here. So if you want questions, feel free to ask them. Other than that, if you're, I'm going to be truthfully honest with you. I really do apologize. It's just like been crazy. Like I said, I'm teaching another class as well. And when we started last week, I just finished my spring classes and their grades and stuff like that. So I do apologize for not getting those sort of graded, but I'm going to do my best to try to get those kind of guys graded. And as soon as I do get them graded, you'll be able to look at them on Canvas and see your grades. So my goal is in the next couple of days to get some of those graded and up there so you can kind of see where you're at, okay, in terms of those. Other questions? Okay. All right, so if you're kind of out, have a good weekend and all that good stuff. If you do have questions about anything over the weekend, you could obviously email me questions if you do have anything like that. But that also means, by the way, that the homework will also be due, right? So remember that the homework for those first couple of chapters will be due on exam day. There will be a box for you to upload that as well. So make sure, you do those as well. Other than that, if you're good, I'm good technically for today. But if you do have questions, I'll still be here. Otherwise, have a good weekend, and I'll see you on Monday. Yeah.